Welcome everyone to Advanced Topics Chapter 1.1. In this class, we're going to be essentially covering college level entry algebra. So all the skills that you have from Algebra 2 combined into a college styled course. So let's go ahead and get started. Now, before I get started I want to mention that if you want to pause, fast forward, skip ahead, rewind this video at any time, that's what it's for. It's in video format, so it's easy for you to get the information you need and kind of fast forward some of the stuff that is review for you, okay? That being said, let's start with linear equations in one variable. A linear equation is in the form of ax plus b equals c. Now, that doesn't mean a whole lot to you unless you have an example. So a great example would be something like 2x minus 8 equals 12. Okay, that's just a great, just basic two-step linear equation that you may encounter. Now, degree, when we're talking about degree, we're talking about the highest variable. So it's always going to be first degree for linear. Now, what do I mean by that? If you look here to this example, there's no 2 written here. This would not be a first degree, therefore it's not linear. So this is 1, so it's good. It's a first degree equation, so that qualifies as linear. Some non-linear examples, so if you want to write some of these down, would be anything where you have like x squared equals 4, or you have the square root equals 16. Those are non-linear because this right here, let me highlight it for you, make it a little bit smaller. Okay, this degree, this exponent is not 1. This is the exponent. Okay, now properties of equality, there's addition, and that means you can add or subtract to both sides. As long as you do something to both sides, you're good to go. Subtract to both sides. I should be doing this in purple. Not sure why it changed. There we go. Style, purple. Okay. And then multiplication. Technically, when you divide, you're multiplying by the reciprocal. So this is when you multiply or divide to both sides. So we can put that into practice with our first equation here. Let's go in green. So we have 2x minus 8 equals 12. In order to get the variable by itself, to find the solution set, and that is all the solutions, all the possible solutions. Okay, so all the possible solutions. What are all the answers? Okay, so when you solve for x, you're looking for all the possible answers, all the solutions. And there may be more than one, even with linear equations, okay? So let's go ahead and start. I guess I'll use orange. The first thing we're going to do is we're going to use the addition property of equality to add something to both sides. We want to get the x isolated, so we add to both sides, and we get, let me go back to green, 2x equals 20. Now we're going to use, and this is actually the division property of equality, but I mean it's the same. We could multiply by 1/2 if we wanted to, but we divide by 2. You guys have all seen this before, and we get our answer x equals 10. And that's our solution set. There's only one solution for this particular linear equation. Let's move on to example 1. Example 1 is a little bit more complex, but the same principles apply. First, you should know that we have like terms here. You got to try to identify the like terms so we can do what I call cleaning up the equation first. Right now we have some stuff that's not cleaned up, that's not combined, so we're going to go ahead and combine those first. So we have 4x minus 2x, that gives us 2x. Those are like terms because they share the same variable to the same degree. It was a dark blue. Minus 5 equals, then we have 4 plus 3, that is equal to 7. And then we have the 6x that stays by himself because he doesn't have any common terms with the 7. Okay, the 7 and 6 don't have the same variable, so we proceed from there. Now, when you're dealing with equations with variables on both sides, number one, you want to take care of the variables first. The reason being it's more efficient. Sometimes you'll move the numbers over, like the 5, you'll move over, and then you realize that you'll have to move the 6 over or something like that. In this case, it's not true, but I'm just saying sometimes you'll make extra steps that you don't need to, so you handle the variables first. And my advice is move smallest coefficient. Okay, so move the smallest coefficient. So we're going to look here, and obviously the 2x is smaller than the 6x, so we are going to move the 2x over. How do we do that? It's the same thing as we do with constants. We do the opposite operation. So if we have a positive 2x here, we're going to do the opposite and subtract 2x from both sides. What happens when we do that? I'm going to go to, let's go dark blue again. Negative 5 equals 7 plus 4x. Now we go from here, and it's just a two-step equation like we did in our first example. We're going to subtract 7. We get negative 12 equals 4x. We divide by 4. Using properties of equality, we can do that because we do the same thing to both sides. This cancels away, or is equivalent to 1 times x, which is just x, equals negative 3. There's our answer. Okay, that is our solution set. There's only one solution, just like in the first example. Moving on to the next one, anytime you have parentheses, most of the time it's going to make sense to distribute. Okay, so we're going to distribute to use the distributive property to the number outside the parentheses and multiply each term inside. If there was 3 terms, we would need to multiply it by all 3 terms. So we have 12x minus 8 equals, what does it equal? It equals 38. Okay, and then I like to carry this minus 2. I like to multiply by the whole minus 2. I don't like to put a minus and then distribute the 2 and then have to count for the minus later on. I distribute the minus to both terms inside. So when I do that, I get minus 4x and then a plus 1. So that kind of makes it a little bit easier. I stay more organized, but just account for that negative 2, and I think it makes it a lot better. Now we have some common terms that we need to clean up here. We have 38 and 1. Those are like terms on the same side, so we're going to do that first. Once we do that, we get 39 minus 4x on the right, and 12x minus 8 stays on the left because there was nothing to combine. Now, like I said earlier, we're going to move the smallest coefficient. That includes negatives. Negatives are smaller than positives, so we're going to move this negative over. If you moved the 12x over instead, you would have negatives. And in my opinion, you want to reduce the amount of negatives you have because you're just more likely to make a mistake with negatives. So we have 16x once we add 12x and 4x. Minus 8 equals 39. So now we need to add 8 to both sides. We get 47 equals 16x. Okay. And then our final, oops, I just noticed I made a mistake. So this is a good thing for these introductory problems. You'll notice here that, yes, it should have been a positive. And you probably think, oh my goodness, why didn't he catch it earlier? We all make mistakes. So that should have been a positive 2. And then that would have led this to be 40. This would have led this to be 40. Okay, there we go. As long as you catch your mistakes, right? 40, and then we divide by 16. Oops, that should be 48 now because we add 8 to it. Divide by 16, we get x equals 3. That is our solution set. Okay, we're going to do, let's see, we're probably coming up on close to 10 minutes. We're going to do one more example, and then we're going to get to the next thing. So for a problem like this, make sure you stick around for this problem. This one is probably one that trips up a lot of students. When you see fractions, it's not as bad as it seems. The easiest way to take on fractions is to first look at the denominators. Pardon me. So we look at the denominators, and we want to see what numbers 6 and 2 both fit into. Okay, 6 and 2 are both factors of what number? So if you wanted to, you could list all the factors of these. So we could say 2, 4, 6, 8, so on, 10, 12. And then we could list the factors of 6, 12, 18, ... Okay? Now look here. You should notice that 6 goes for both of them. So that is going to be our least common denominator. Now, why is this important? We want to know this because once we multiply that least common denominator to both sides, it's going to eliminate our fractions for us. So we're going to multiply 6 to both sides. And let me show you how this works. When we do this, we need to distribute the 6 to every term inside the equation, okay? Term meaning separated by addition or subtraction. So we have x plus 7 over 6 times 6 plus 2x minus 8 over 2 times 6 equals negative 4 times 6. What does this do? Well, let me do this real quick. I just want to make this a little bit more organized. Okay, style. Let's make it that pink color. Okay, good. A subtle difference, but hopefully you guys see the point. Okay, now what does this do for us? Well, it's going to cancel most things that all the fractions actually. So it cancels completely with this guy, the first term. Here we have 6 divided by 2, and we're going to be left with 3 in the top, so there's a 3 remaining. And then we can multiply negative 4 times 6, which gives us negative 24. So now we have x plus 7, that's by itself. We have plus 2x minus 8. We need to put it in parentheses because it's still being multiplied by that 3. Moving on from here, we need to distribute again. Now we have no fractions. See how that eliminated all the fractions? By multiplying by the least common denominator, we don't have to add fractions. We just need to multiply and cancel. Makes it way easier in my professional opinion. Now we're going to distribute, okay, the 3 to both sides. We have x plus 7 plus 6x minus 24 equals negative 24. We're going to add 24 to both sides, just so you can see that 0. I mean, I guess honestly, we should probably combine these first, but since I already did it, we're going to go ahead and roll with it. We get 0 equals, now I should combine these guys, the x and the 6x. So I'm going to combine those to give me 7x, and then I still have that plus 7 I forgot about. That's okay. Now we're going to subtract 7 from both sides, subtract 7. Now we have negative 7 equals 7x. We divide by 7 to finish it off. We get x equals negative 1. That's our solution set. All right, I'm going to cruise through. I guess we have about one little table left, and really it's not that bad. I think I can finish this in 2 minutes if you want to time me. If not, just jump ahead inside the video. So conditional, this is a fancy way of saying that there is one solution. So if there's an equation that is conditional, that means it is one solution. Its set is going to be one number. So it's going to be a number inside the solution set. So x equals a number. Okay, the final line once you're done solving is going to be x equals a number. And I'm going to write number like this. I like that a little bit better, a little bit more clean. Okay, now it shouldn't say identify. It should say identity, so make sure you turn, I think that was trying to be fancy. So just in case you're not clear, that should say identity, okay? Now, this is when there's infinite solutions. So if an equation is an identity, that means there are infinite solutions. So you can put all real numbers for the solution. That's the solution set. That means every number works for that. And oftentimes what you're going to get when you're done solving is you're going to get 0 equals 0. Okay, now a contradiction is when there is no solution, also known as the null set, no solution. And you'll get something like negative 1 equals 5. You're going to get something that doesn't make sense, and that means no solution. That means that's a contradiction. I'm mostly concerned, for those that are my students, I'm mostly concerned with this. The names are secondary in my opinion. If you don't know exactly what a contradiction equation is, I'm okay with that as long as you know what this means right there, okay? Identity is a little bit more important, but same deal, okay? Now, distribute here. We have 5x minus 20 equals 5x minus 15. Now, we start with our variables first. We subtract 5x. We get negative 15 equals negative 20. We see that we have a problem. This is not true. This is no solution. Okay, the null set. There's no answers that satisfy this. Make sure you guys tune in for next time when we talk about formulas and percentages in section 1.2. Thanks for watching.